Greetings everyone, my name is Gaurav Sarve and today I'll walk you through an exploratory data analysis of global terrorism data. That is my project. Our goal is to understand patterns in international terrorist attacks using the Global Terrorism Database. In short, we say it as GTD. By analyzing this data, we can gain insights that inform policy and public safety. Firstly, I'll be explaining you guys what is exploratory data analysis. In short, EDA. It is essentially about exploring and visualizing the data to discover its main features and any hidden patterns. In simple terms, it visualizes the data to understand its main features, find patterns, and discover how different parts of the data are connected. It involves plotting the data distributions, examining summaries, and using charts to reveal trends. As IBM notes, EDA helps analysts to analyze and investigate the datasets and summarize their main characteristics, often employing visualization methods. In this project, we apply EDA to the GTD to uncover key trends in terrorist incidents worldwide. Now, I will be beginning with my project. As we all know, in the recent years, terrorist attacks have become more frequent, widespread, and varied across the world. To study and understand these complex events, researchers use EDA, as it helps by cleaning and checking the data, spotting patterns, and finding hidden trends. Also, showing results through clear visuals before doing an advanced modeling, as I've already explained you guys previously. One of the main sources used is the Global Terrorism Database, which has the details of over 200,000 incidents from the past 50 years. By applying EDA to this large dataset, analysts can identify hotspots, understand how terrorism changes over time, and measure its human and economic impacts, also detecting early warning signs. The overall goal is to provide insights that support security planning, policy making, resource allocation, and prevention strategies, while also communicating findings in a simple way to the decision makers and the public. Before we dive into the analysis, let me introduce you to the Global Terrorism Database, in short GTD. It is the world's largest open dataset on terrorist attacks, covering incidents since 1970 with over 200,000 records, as I have already told you guys. It is maintained by the University of Maryland Start Center and collects information like date, location, type of attack, targets, weapons, casualties, and responsible groups. The GTD uses AI, artificial intelligence, human coding, and thousands of news and research sources to ensure accuracy. It includes both domestic and international events from bombings to kidnappings, while some gaps exist due to reliance on media reports. The GTD remains the most trusted source to study terrorism trends, hotspots, and policy impacts worldwide. Now we will see some security issues and insights derived by EDA. EDA reveals key security issues, major hotspots like Afghanistan, Iraq, and Nigeria and India, rising diversity in attack methods, common vulnerable targets like civilians and government, deadly but rare high casualty events, and the fact that a small number of groups drive most terrorist activity. EDA also provides some actionable insights by helping prioritize resources, forecast risks over time, evaluate policy responses, protect vulnerable populations, focus on the most dangerous groups, and stay aware of data limitations for reliable analysis. Next, I'll demonstrate the coding setup for exploratory data analysis. I've used the language Python for my project. Step 1. Begin with installing the main Python libraries for data manipulation and visualizations. As you can see, I have installed some libraries which will be helpful for our data analysis. Step 2. Load the GTD CSV dataset, as I have already downloaded the GTD file to my system, and now I am loading it into the Python using pandas. This way, we can start exploring the data directly. The third step in our workflow is data cleaning, which is essential for reliable analysis. In my dataset, I dropped the missing values and irrelevant records to make the data consistent, accurate, and relevant for the EDA. Now, I'll be showing you guys the basic trends. I have termed it as temporal analysis. I have used these codes over here to plot this chart. So this chart is nothing but a line chart. It shows the number of terrorist attacks yearly from 1970 to 1977. I have used line chart because it connects the data points with the lines to display trends or changes over time. As you can see, the number of attacks went down from 1970 to 1971 and again in 1973. Then it went up a lot in 1976, and after 1976, that number of attacks went down again in 1977. Now, we will be looking at some geographical hotzones. Basically, it is nothing but attacks by region. I have used these codes over here to plot this chart. This chart is nothing but a bar chart. This bar chart shows the number of terrorist attacks in different regions. As you guys can see, Western Europe had the most attacks, followed by North and South America. Other regions like East and North Africa, Australasia and Oceania has very few or almost no attacks. Now we will see attacks by country. I have used these codes to plot this chart. So basically the code counts the number of attacks per country in the data frame using value counts. It takes the top 15 and plots them as a bar chart using Seaborn. As you guys can see, the graph shows the top 15 countries that faced the most attacks. The US, United States, and the UK, United Kingdom, are at the top with over 1200 and 1000 attacks respectively. Other countries like Italy, Spain, and Argentina follow with fewer attacks. Now, I have analyzed some attacking patterns of terrorists. So, I have used these codes to plot this graph. The code plots a bar chart of the most common attack types from a data frame, and it creates a bar plot with attack types on the y-axis and the count on the x-axis. So as you guys can see, this graph shows the most common types of attacks. First, bombing / explosion, or we can say the bombing and explosion is the most common, and it is followed by assassination and armed assault. Other types like facility / infrastructure attack and hostage taking are less common. I have analyzed the target types as well. I have used these codes for the analysis. As you guys can see, this graph shows the count of different target types like business, military, government, etc. Business is the most common target type, and it is followed by private citizens and property, then military, then government diplomatic, then government general, and so on. Okay, now let's move to the impact analysis. Here, I have used these codes to get the output. The output shows the top 10 deadliest terrorist incidents based on the total number of casualties. The table lists the year, country, city, and the number of people affected in each incident. For example, the deadliest incident was in 1976 in Baghdad, Iraq, with 295 casualties, followed by London, and then Belfast, then Nairobi, Brescia, Lord, Malot, Birmingham, Buenos Aires, and Birmingham. Looking at this table helps us understand where and when the deadliest incidents happened. After the impact analysis, I have also found the perpetrators. Perpetrators simply means the people, groups, or organizations who carried out the terrorist attack. I have written this code. Basically, the code creates a bar plot showing the top 10 terrorist group attacks by count. In this code, I first counted the top 10 terrorist groups from the dataset using the gname column. Then I used Seaborn to create a bar chart where the x-axis shows the number of attacks and the y-axis shows the group names. I set the figure size to make it clear, added a title and labels, and finally displayed the chart. This helps us quickly see which groups are responsible for the most attacks. This graph shows the top 10 terrorist groups by the number of attacks they carried out. Unknown is the group with the most attacks, over 1200, followed by the Irish Republican Army, in short IRA, and others like Protestant extremists and left-wing militants. Finally, I also prepared a complete storyboard for the project to ensure a clear flow of ideas, smooth transitions, and effective presentation of insights. Firstly, the exploratory data analysis on the Global Terrorism Database uncovers the patterns and trends, identifies security insights, and analyzes over 200,000 terrorism incidents. Then, I have shown the dataset overview of the Global Terrorism Database. So, the Global Terrorism Database records over 191,000 attacks across 163 countries from 1970 to 2020. These incidents have caused more than 42,000 casualties with both civilians and officials among the targets. Then, I have used line chart to represent the global trends in terrorism. Next, I presented the geographical hot zones, and from this chart we can clearly see that the country Iraq has been most affected country by terrorism, followed by Afghanistan, Pakistan, India and Nigeria. Then I have shown attack patterns and methods in which bombing, explosion remain the most common attack method, far outnumbering other patterns, and then armed assaults, assassinations, and hostage takings follow but with significantly lower frequencies. Then I have shown the target profiles using pie chart. Nearly half of all attacks target civilians, making them the most vulnerable group. The military, government buildings, and businesses follow as secondary targets. Also, I have done the human impact analysis in which it shows that terrorism has claimed over 167,000 lives and left more than 245,000 injured. Major attacks like 9/11, Baghdad bombings, and Garissa University highlights the scale of devastation. Also, I have shown the perpetrator group trends in which the ISIS leads as the most active group, followed by the Taliban and Boko Haram. Other groups like AQAP, Al Shabaab, and smaller fractions also contribute significantly. Now, security insights and recommendations tells us that high-risk regions show a rising trends of incidents pointing to the increasing threats. Risk profiles and threat levels help identify and prepare for future attacks. Lastly, the main objective of this project is to perform a thorough exploratory data analysis on the Global Terrorism Database to uncover actionable security insights, identify hidden patterns, and support data driven decision making for law enforcement, policymakers, and public safety stakeholders. The core objective is to transform raw terrorism data into meaningful knowledge, the knowledge that helps us understand where, how, and by whom terrorist occurs, so that the better strategies can be designed for the prevention, preparedness, and protection. In summary, all these objectives together help improve our understanding and management of global terrorism through empirical, data driven approaches. By relying on evidence and patterns from the real incidents, we can move beyond assumptions and support stronger security, smarter policies, and safer communities. Thank you.